Let's get it started. Welcome everybody to the presentation called Spring Cloud's Groovy. My name is Marcin Grzejsczak. Yes, you can. It's possible to pronounce it, even though there are only two vowels. So today we're going to talk about Spring Cloud and Groovy and Gradle. So before we start, maybe I'll say a few words about myself, because I'm pretty sure nobody knows me. Oh my God, the face is so big. So I'm a developer at Pivotal, being a part of the Spring Cloud team. By the way, who knows Pivotal here? Okay, most people. Who is working with Spring Cloud? Okay, one person. Awesome. So apart from working on Spring Cloud on the daily basis, I work quite a lot with open source stuff. So yesterday, Olga was talking about Accurest. So I wrote most of it, I guess. I created a library called JSON Assert for fluent JSON assertions. That's why the name, JSON Assert. If you're using Spock and you loved inject mocks in Mockito, I wrote a Spock subjects collaborators extension. But actually, it would be better if you don't use it, because it means that your code is cleaner. Actually, from what I know, people tend to use it to hack their bad code. So better write good code. And also a Gradle test profiler to actually profile your Gradle tests that you can run with Gradle. My Twitter handle is Grzejsczak. So I guess if you type the 4 first letters, you should find me. And my blog is toomuchcoding.com, where I blog about Spring Cloud and all of the things that you can see here. Okay. So what's on the agenda? First, I'm going to tell you what are we using Groovy for at Spring Cloud. Then, in order to show you how we're using Groovy and Gradle, I will need to give you a very, very short introduction to what distributed tracing is, so that you get the examples that I'm going to show you later. But it's going to be a very short introduction. Then I'm going to tell you why I chose Gradle for the test that we're doing, and why it was the best choice in order to test our stuff. And then I'm going to show you how we're running tests with Spock, how we're building reports. And if the demo gods and my pointer allows me, I'm going to show you the demo of whatever I'm going to show you on the slides. Okay, so let's start with the first one. What are we using Groovy for at Spring Cloud? Okay, so there's one project from what I know, it's called Spring Cloud Zookeeper for integration with service discovery called Zookeeper. So over there, I've written Spock tests. So I think this is the only project where we don't have any or very little JUnit tests. But other than that, we are doing end-to-end tests of Spring Cloud. And what are we testing with those end-to-end tests? So all the service discoveries that we have, Zookeeper, Consul, Eureka. Also, okay, I'm not going to use it. We're testing integrations with the Netflix stuff, so Zuul, Ribbon, and Feign. And the brand new thing called Sleuth. Yes, this is actually a word. I didn't know that. It means a detective. So Sleuth is the library that we created for distributed tracing. And today we're going to focus on that one, and I'm going to show you some tests related to this one. So now let's go to a very, very quick introduction to what distributed tracing is. So in general, in modern applications, I'm pretty sure you know it already yourself, that modern applications are a gigantic net of interconnected components, right? Often when you come to a project, you're a new person, and you ask somebody, I mean, do you know how exactly and what talks to what and how? And it turns out that there is one guy somewhere and it's like a tribal knowledge, right? That somebody hid this information under some stone, and he only knows that, and thanks to this knowledge, he will never get fired. So it's not the way it should be. Also, for sure, you've got Confluence or something like that, and the moment you type in the stuff there, it's already outdated. So it would be good to have immediate glance of what you have, for example, in production, how it looks like. Also, it would be great to not only visualize the system's topology, but also see the performance issues. Often, let's say you run some, let's say you deploy a new feature, and then you check the production metrics, and it turns out that something's wrong somewhere, right? That the users say that the system performs in a bad way, and now you have to, if you have the metrics, you have a bigger chance, but often you don't, and now you have to guess where the problem is, right? It would be good to immediately know about this, where the problem most likely is. So, there is such a thing called Dapper, which is a large-scale distributed system tracing infrastructure. They created that at Google, and there's a very good paper. I advise you to read about this, where they define what kind of problems they had and how they solved them. And especially, I'm mentioning that because in the later part of the presentation, I'm going to use some terminology from the Dapper paper, but I'm going to explain it in a second. So the first thing that that we're going to, let's say it's the last thing actually, that we're going to test is integration with Zipkin. Zipkin is a distributed tracing system that it helps you gather the data needed to troubleshoot latency problems in microservice architecture. So this is like the missing piece where you can see all the parts of your system's topology, how much time is spent on which operation. I'm going to show you that in a second. And the front end of Zipkin is like Waterfalls digraphs. So it shows you the call durations as horizontal bars. And this is really cool. It allows you to draw the graph of dependencies of your system. So once you plug it in, you, for example, use Spring Cloud Sleuth, you immediately can sketch on production the topology of your system. And in our end-to-end tests, only fairly recently, unfortunately, I could have done it before, earlier, we're explicitly checking this graph of dependencies. So now Spring Cloud Sleuth, it's an implementation of a distributed tracing solution for Spring Cloud, and borrows Dapper's terminology. So we're compliant with Dapper. And it's crucial that it integrates with Zipkin, but doesn't really have to. So you can have, for example, log correlation without integration with Zipkin. In our end-to-end tests, we are not checking the logs. We are checking exactly the integration with Zipkin as far as Spring Cloud Sleuth is concerned. In terms of service discovery, we completely ignore this integration. So now, terminology. So there's something called a span. So a span is a basic unit of work. So if you send a message over a wire, it's a span. It's a basic unit of work. So spans are started and stopped. They have also a notion of duration. So they keep timing information. So if you send a span, you receive a response and you stop it, then you know how long did it actually take. And once you create a span, you must stop it at some point in the future. We're not testing that. Actually, we do test that also in the end-to-end test. So we ensure that even though everything seems to be working, we want to ensure that there are no stupid issues, no warning messages and stuff like that. Okay, so now we know what span is, so let's move to what the trace is. So if you have multiple spans, you create a trace, because a trace is a set of spans, and they form a tree-like structure. So, for instance, let's imagine that you have a bookstore, and somebody sends a request to receive the list of all the books. So that can be a trace. So if underneath there are 200 calls being made, all of them form one trace, even though there are 200 spans, for example. Okay, and now to the awesome animation that I've done. So here we have a service 1, and a request comes in. And there is no trace ID and no span ID. It's the first request coming to the system. Now we've provided the trace ID and span ID. Let's say the trace ID is X and span ID is A. So if a service 1 calls the service 2, then Okay, then the trace is the same, right? But there's a new span, so span ID is B. The server side receives the information, and it, let's say, stamps an event on the span. Here you can see that the client, there is a client sent event, and here you have a server received event. And we're testing that as well in the of course, unit integration and end-to-end test. Because we need to be sure that not only, let's say, this guy sent a message and he got it, but that there are proper entries on the structure. Now let's assume that we're moving forward, please. So if there's some logic done in service 2, another span is created, and so on, and so forth. And now let's go back, right? At some point we have to receive a response. So as you can assume, I've colored let's say, parts of one span with the same color. So service 2 sends a request to service 3. So client sent event has been attached. Here server received event has been attached. And now we have to go back, send the response. So we say that server sent event occurred. And once service 2 completely, let's say, receives the response from service 3, the fourth event is passed. So actually, the whole RPC scenario, like sending and receiving, these are 4 events. Client sent, server received, server sent, client received. And so on and so forth. So actually, the most important thing is that this is a very simple example, right? I'm going to show you an example where we have, I think, 12 applications, or something like that in general. And we have to ensure that this trace ID at the end, passing through everything, remains X here, like I've shown you here, X. And imagine how difficult it is in case where you have RX Java, custom thread pools, stuff like that, where you have to always pass this information on. And actually, in our end-to-end tests, I mean, the example is bloated with stupid usage of things that there should, I mean, like calling hystrix from hystrix via a custom thread pool and stuff like that, only to tangle it so much to ensure that at the end of the day, we're passing forward proper information. So I told you that it's presenting a tree-like structure, and also we're checking this structure in the test. So if we had the first span with ID A, it was the first span that came into it was created in our system. Then if we create the next one, then the second one has the parent equal to the first one, right? It's a tree-like structure. At some point, you could see that service 2 called service 3 and service 4, so they both have the same parent ID, right? And here starts the cool things. This is the screen from Zipkin, because actually you can agree with me that it's better not to sketch a graph like that. It's better to have such a graph. And this is the graph of a running system. And it shows you the calls being made within the system. Last year I've been doing a lot of talks about a library called microinfraSpring, made in Groovy, which was a library related to, let's say, microservice communication, however we call it. We had something similar, but it was declarative. So you declared that your microservice talks to those people. And then we have sketched a graph. Here, it's after the calls have been made, you can see what happened, right? So this is actually most likely the truth. So let's take a look at an example. So this is what we just saw. And here you have endpoints, start, full, bar, and bus, right? So this is the Zipkin UI, where you can see the calls being made and how much time, let's say, some processing took place. So here you can see service 1 and HTTP start. So a request was sent to the start endpoint. Then we have 2 spans, one for the client side, one for the server side, of the foo. endpoint, right? So this is the start, and this is the full endpoint. So here you can see that 1.6 of a second took place in HTTP full, right? I wrote this code, so I know that inside I have a lot of thread sleeps. That's why the bars are long. But let us assume that you're doing high-frequency trading, and suddenly you see a graph like that. So immediately know that something is wrong. That processing of a request takes 1.8 seconds. So it can immediately visualize the problems with performance. And if you click on one of the spans, for example that one, you can see all the annotations that I told you about, and we're checking them in the tests. Is someone sleeping? It's not that boring, I guess. Okay, so this was a short introduction to distributed tracing, and why did we choose Gradle to test Spring Cloud stuff? So what was the most important for us is to, apart from having good unit and integration tests, we wanted to see all the building blocks working together, right? In Spring Cloud, we have so many integrations that I wanted to have certainty, or like bigger probability, that everything is working together. I wanted to see that. I wanted to click around, see that, and let's say make it test that in an automated fashion as well. And this is crucial. I didn't want to write different test apps for different libraries, because we already have a lot of test apps in Spring Cloud, but I wanted to have one test application with which I could test all of the things that we have, even though some are exclusive, because I don't want to deploy two different servers used for service discovery, because it's stupid. I want to have only one. Next, I wanted also to write such a solution that I could test on the on the Cloud Foundry, Pivotal Cloud Foundry, which is a pass by Pivotal. So I wanted to be sure that if I run the test locally, I can, let's say, run the very same test on something deployed in the cloud. So it had to work in a fully automated way in both cases. Also, that was my personal desire, is that before joining Pivotal, I heard that Spring Cloud allows you to have such an abstraction over service discovery that you can change, for example, Zookeeper into Consul without a single change of code. Like, you just change the jar, change the configuration, it's working. I wanted to prove that because it seemed like too good to be true, right? So I needed a solution where, without a lot of work, I will be able to combine different configurations of things that I want to test. Also, what was really important for me is that when I was developing the test application, I wanted it to be very easy for me to have access to the class path and stuff like that. So I didn't want to reload the IDE, because right now I want to work with Consul, for example, or with other stuff. So I wanted the IDE to give me all the possible blocks, all the possible tools, whereas at runtime I wanted my Gradle build to choose the building blocks that would create the jars at the end of the day. Yeah, so this was one of the key reasons that, key requirements, that no IDE reloads is necessary, right? Because you don't have in Gradle like Maven profiles, right? So you'd have to change it, adopt them somehow. So I wanted to have everything present there during the creation of the app, but at runtime I wanted to be selective. Yeah, also, since we have a BOM that describes the versions of different libraries, I didn't want to control that. I wanted to only pick the version of the BOM, right? In a very, very simple way. Yeah, and we managed to do that as well. Okay, so this is our test application. Actually, last year I've been giving the talk about this application a lot. So this is an application to brew beer, right? In general, it works like this, that you have 4 components, so to say. This is the first one is the UI, so it's the presenting service. It's a separate microservice. These 3 parts are embedded in a service called brewing. And what you can see to the left is the amount of ingredients that you can order to brew the beer. So in order to brew the beer, and if any one of you is like doing beer at home, so sorry for any mistakes that I'm going to show here, you need 1,000 units of malt, hop, water, and yeast. It's obvious. And if you click order and you have 1,000 units of each of those ingredients, the brewing process starts. So here you have gauges that show the amount of items that are being matured at the moment and bottled. And at the end of the day, we're showing how many bottles we have. At different presentations, in order to make it, like to have this wow factor, we had thread sleeps in those parts so that a lot of items show up here. But for the tests, I wanted it to be very fast, so most likely we'll be able to see 1 at most here. So this is another graph that shows you how your system looks like, right? So again, it's not as nice as the one from Zipkin, but it shows you the interactions in the brewery. So here we have the user clicking something on the UI. Those 3 boxes are parts of a brewing service, so it's a 1 jar. So actually, those servers are the separate jars. So altogether, we have 1, 2, 3, 4, 5 jars, plus, for example, Spring Cloud config server is the 6th one, Eureka is the 7th one. We have to run RabbitMQ as well, so it's the 8th one. So if I run it on my laptop, it almost melts. But the idea was to really have separate applications talking to each other. So the user clicks something on the UI, he orders ingredients. Let's assume that he orders the 4 necessary ingredients. Then a request is sent to a Zuul proxy that forwards the request to the ingredient service. So here we're checking if our integration with Zuul is working fine, and service discovery, because those applications are not talking like, with a hard-coded port, but via service discovery. Then the response comes back. So we are ordering hop, malt, yeast, and water. We're sending back the response. And here we have a poor man's CQRS, because we are emitting events. And here you have a reporting service, right? That is, let's say, consuming those events and populating the poor man's database, which is a hash map. And once the beer processing is done, we send the information back to the UI that, hey, the UI is polling for information to the service that, hey, the beer is bottled. This looks much nicer, doesn't it? This is the very same graph showing you the dependencies, and we are explicitly in the end-to-end test. We're checking who's if this graph is there, because we can get the graph in a JSON format, and we're checking if, for example, brewing is the parent of Zuul and reporting in terms of service calls. So we are explicitly checking that. With JSON Slurper, of course, because I would never. I did it once. I had to migrate JSON Slurper to Java. Somebody showed yesterday a great image with somebody like destroying his eyeballs like this. So I felt it. It's terrible. I saw things and I'm never the same person again. So okay, this is the graph of spans. All the calls that have to be made to brew the beer. And like I told you, I have a very stupid example, a simple one, and there are 50, you can't see it actually, 56 spans. So 56 calls are made to brew the beer. In your systems, I guess it's going to be much more, right? And we're checking, I'm not explicitly checking the order of those spans. I'm checking if some, let's say, spans exist there. So I'm for the given trace, because these are all the spans that are present there for a single trace. So I'm checking if certain names appear there, because if I did, a check like one after the other, if the order is proper, the test would be extremely brittle, and I didn't want that to happen. Okay, no need to reload the IDE. That was this important feature of the test. So I wanted to ensure that service discovery is working, that apps can talk to each other, and there are two means of communication, via REST template and via Feign, right? So what was important for me is that I didn't want to restart the apps to change the approach, right? Imagine that, all the deployment of those 10 applications takes some time, right? So in order to just change the means of communication, I would have to redeploy everything, and that was unacceptable. So you can do it in a very simple way. You have to design your app to know that there are different means of communication. So from my tests, I'm going to show you that afterwards, I send a request with the information in the headers that I want you, dear application, to use Feign for communication, right? And then I had to, inside the service, create such an approach that it copies the headers to like in the next call. In that way, I could parallelize the test and choose at runtime which means of communication I want to choose, right? So I have an awesome switch in the code where I check, this is a thread local, so disregard that. I check what kind of test communication type has been passed. If it's Feign, use Feign. If it's anything, I'll use REST template. So in a very easy way, if we define a new way of communication, I can just pick in the applications another way of, let's say, calling. So this is a very similar approach to test data in tests, right? So for example, you want to have in your databases on your deployed applications the possibility to run tests on production. So you have to run from the very beginning your applications in such a way that they can discern test data from production data. So here it's the same. Now, what did we want to test? That Sleuth is working and proper spans were created and transfer information got propagated. That's obvious. And now off to the Gradle Meet, so to say. Can you see that properly? Yes? Okay, so the very most important thing was that I wanted at runtime to choose what I want to test. So if I create a jar with an application, I wanted to choose if it's going to contain the Consul or Eureka or anything else. So here you have a what to test closure that gets like a property name. And what I'm checking is that if I executed Gradle with a what to test system parameter equal to something, for example, Consul, right? I'm going to show you an example in a second. And then in the dependencies section, I say that if what to test is Consul, provide Consul discovery. If it's Eureka, provide Eureka, right? So I have such Gradle scripts executed, for example, what to test equals to Eureka or Consul, whatever. And okay, so this is how I run it, right? And then inside the app, I know what to how to process this information. And how I do that is that first is the what to test closure, and the other one is module enabled, because I didn't want to, for example, build projects that I don't need. I wanted to skip them, but I wanted to have them in the IDE. So I couldn't let's say in the settings Gradle conditionally not import a project. I wanted all the projects to be imported, but I wanted during the build process to disable all tasks of a module. So here I just created another closure called module enabled, and I combined it with what to test. So if somebody passes like Sleuth stream as a what to test thing, the module will be enabled. If not, all the tasks of the module will be disabled. So here you have an example. If I run like what to test equals to Consul, all the Zipkin server tasks will be skipped. And you can do the very same approach in your builds to speed up the building process. Last year, I guess, I published a post on my blog how I went down from 90 to 8 minutes on the build in Gradle. And these are the approaches that you can take, like skipping unnecessary builds and stuff like that. Okay, another thing that looks cool, but actually we stopped using it, is creation of Docker files. So I created a closure that has a single argument called port. I create all the necessary stuff in terms of exposing ports and things like that. What's crucial is this is a closure, right? And for each of the projects that I needed that to happen, I'm creating a task of type Docker where I curry in the port. Who has used curry in on the daily basis? Is using curry. So very few people. You rarely need that. So what is that actually? The Docker project, the Docker task needs a configuration closure, right? So I don't want to execute this closure. I want to pass a closure, but with a certain port. So what I do here is that, for example, if I have an application for which I want to create a Docker file, let's say with exposing port 9992, I just execute this closure, and I pass a closure, not executed one, just a closure, with a fixed port of 9992. So take a look at curry. It's a really useful option if you have to pass around closures and not execute them. Why we chose Gradle also? Because of the separation of configurations. So I really personally enjoyed that, because if you have big multi-module Maven projects, at some point the 1,000 lines of XML are really hard to take a look at them and to group things together. So here I could group in lists projects that I let's say have common approach to things. So if I had Zipkin related projects, so these are all the sub projects that are not non-Zipkin ones, I could pass them a dependency with Zipkin, right? But only if somebody wants to test Sleuth. Running the tests for the provided version of a bomb was very simple. Because we're using dependency management and we have a Gradle property defined called bomb version, right? So we can only override the version of the bomb and let's say in an automated fashion. Actually, what we're doing is let's say initially what we did was a simple hack. Then we changed it into said that if you have Gradle properties and you want to change one property into another, you can just append it at the end of the file, because that one will be taken into consideration. So you don't have to find and replace. You can append it at the last place. Since I'm waiting for Andre to do the sugar with local command executions, until then I had to run the tests somehow. So I run them with bash. Ignore the options, if you clone the sample, you can check them out. But it's as simple as running a bash script with some options. And essentially what they're doing, they are running Gradle with proper values and checking if applications are alive or not. That's it. So hopefully I will be able to rewrite it to sugar. Thank you. So that was why we chose Gradle. Now let's move to Spock. So how are we testing things with Spock? So we needed to run the same test for both Cloud Foundry locally. That was very important for us. And run the same test. I didn't want to have tests defined in different places for different applications. I want them to be in the same place. Also, that was crucial after I accidentally ran wrong tests. So I wanted to ensure that I execute only related tests. Because afterwards, our Bamboo build said that the build is successful, whereas it wasn't. So we wanted to ensure that only related tests are executed. And also it's important in terms of the speed of building your app, right? If you ignore unnecessary tests, the build is faster, which is obvious. Yeah, if you don't provide any property like what to test, the build should fail, fail fast. So this is an example of the Spock test that I wrote for Sleuth. Sleuth testing. So let's go, because I don't have much time, it seems, through it together. So let's start with the upper section. Who knows about the requires annotation in Spock? Okay, quite a few people. It's very cool because, again, you will run the test only for some conditions. So if you don't pass them, the test gets ignored, and the build is faster. So here, I wanted to ensure that I run this test only if you want to test Sleuth, because it's a Sleuth test. Makes sense, right? So what is this Sleuth? Oh, you could see here, test conditions.sleuth. Sleuth is just a closure where I check if the what to test system property matches any of these, right? So if somebody passes a system property what to test equals to Sleuth, then the test will be executed. I told you that I wanted the test to be failing if you don't provide any property. Another annotation, ignore if. So if somebody passed the system property and it's valid, this test should be ignored. If he didn't pass the system property, it should fail. Like, I'm running a very specific exception here, right? You should understand it, right? What to test system property not passed or is wrong. So yeah. Now, yesterday, I don't remember who, but somebody mentioned Spock Reports. This is awesome. Start using that. Here, you can see the, let's say, labels that Spock Reports will take into consideration when building the final report. So you can see that you can read it like a book, right? So the presenting service has been called with all ingredients. Eventually, beer will be brewed with same trace ID as the first request. An entry will be present in Zipkin and dependency graph is correct. If somebody doesn't understand that, I don't know how to write it otherwise, right? And if you see at the bottom, this is nice because you have a where clause. I'm pretty sure you're accustomed to having a where clause in form of a table, but you don't have to have a table. Here, I want to run the test for REST template and Feign, but I want the reference process ID to always be created like that. So here you have a matrix where the first thing is the communication type is REST template, and the reference process will be, let's say, A, and then you test it with Feign, and reference process will be B. So this part will be executed at each time the first one is picked. This is the screenshot from Spock Reports. So you can see the labels that I showed you. There are two tests, because one is for REST template, one is for Feign. And you can see that the process IDs are different here. So they have been generated each time an iteration of the where clause took place. And yes, I had to wait for some time for all the builds to be green to do the screenshot. But we're running the end-to-end tests every 3 hours because I want to be sure that somebody didn't introduce like a breaking change in the meantime. Mind you that if you have, for example, Travis builds, they are only executed if you push something, right? So if you depend on other libraries and they got broken, it's good to know about this as soon as possible. Okay, so now a very, very quick demo. Okay, so this is the code of the brewery. Okay, can you see that? So this is the test that I showed you a couple of seconds before. So the first thing that I'm going to show you, or maybe I'm going to show you first the project. So here you have like quite a few modules, as you can see. I can see them all in the IDE, so I didn't have to reload anything. There is quite a few conventions going on. So we're using Docker Compose, but only to boot up RabbitMQ. So if RabbitMQ had a wrapper or something, I wouldn't use Docker Compose at all. And just check the README for more information, because I don't have time to show you all the project. So let's run the test where I don't provide the property, what to test, right? So I run it. And most likely something will happen. Of course, the demo god. Okay, let's just. I'm really happy. Oh, let me try it again, maybe. Of course. Believe me, it would fail. So let's take a look at something else. Let's take a look at the brewery. So you can see that most likely it will work. Oh, come on. Not again. Okay. It worked on my machine like an hour ago. Yeah, let's go back to the presentation. It's ridiculous. It happened like at the last time I was doing the presentation. Never mind. So, summary is like this, that demo gods hate me. The second thing is that using Gradle, we are able to create highly customizable projects just by changing a property. So you change one single system property and you build a completely different system, right? Composing of different blocks. And from the developer's point of view, it's very important that he doesn't have to memorize any Gradle foo and stuff like that, like magic. He just has to pass the property. With Groovy and Spock, we've managed to create tests that are very readable and platform independent. So if anything worked here, like during the demo, including the internet, I could have called the very same test to the cloud and have the result back. Actually, it's exactly what I'm doing in Bamboo. Every 3 hours, I deploy to the Cloud Foundry all the applications, and then I run the tests. The very same test from the very same repository against the apps that are deployed in the cloud. And this is really important for me, because I don't like end-to-end tests. But why? Because they are very hard to debug. Because everything can go wrong. Like even network issues can appear. I mean, seriously, everything can go wrong. So my advice to you is to write very good unit and integration tests and have only a handful of end-to-end tests. Because I saw the inverse pyramids already, and it's unmaintainable. It's a disaster. But end-to-end tests helped us already to find quite a few bugs. So it's not like you shouldn't have them. In my opinion, you should have a small amount of them. Okay, so here you have the links to the GitHub project with Sleuth. Here you have the documentation of Sleuth, and this is my blog post about the recent deployment of Sleuth. Here you have the brewery sample, where you have, I think, quite a good documentation about how to run the examples. You can check the build Gradle, and if you like any of the ideas, just copy them. And here is the rationale behind end-to-end tests. Actually, that was my first post on the Spring blog, where I explain why even we got that way, and I explain the rationale behind writing the end-to-end test in such a way as they are written. So you can check them out, and I think we have some time for questions, if you have any. Any questions? Okay, so you have no questions. Okay, go ahead. Okay. Yes, that's a good question. So the question was about Sleuth. What's the cost like in terms of instrumentation of the different libraries? Actually, I can point you to the test that we're running, because we're like 2 weeks ago, I think I wrote benchmark tests that test Sleuth in 2 ways. One is using JMH or JHM, so it's the benchmarking tool, and the second one is using JMeter. So using Spring Boot plugins, we're starting some apps and running the JMeter stuff and checking the results. So from our let's say calculations, it's like negligible. It's I don't know, 0.1 of a millisecond, something like that. So it's really, really small, assuming that we wrote our benchmarking properly, right? Because it all depends. We're going to for sure improve the benchmarking stuff, but for now, it's negligible. Yeah, go ahead.
What's the mechanism for passing the trace?
Yeah, okay. No. So you say, what's the mechanism to parse the trace?
To pass
To pass, okay. So there are like bazillions of mechanisms in order to instrument stuff, but inside the apps, we have a thread local. So inside the thread local, we keep the information about the trace, and then is our job, which is a really hard job, to believe me, to pass it between different libraries, different things in general. For instance, if you have REST template, we have to have a custom interceptor, because you have a REST template and you're sending a call. So we need to intercept your call to pass all the tracing information in headers. In this case, in case of HTTP, but we have also instrumentation of messaging, so we put that via Spring integration into the message headers, and yeah, it's a lot of work there. So, the end. Thank you.